So we're going to spend large part of 45 minutes to an hour talking about a few things to do with security in Azure. It's one of my favorite subjects in Azure for me as a consultant to talk about, to kind of give you that insight into how this actually works in terms of protecting yourself, make sure there aren't kind of any kind of silly configurations going on where you don't quite understand how certain things work, but you want to be able to have that knowledge and have that understanding in terms of how we can actually secure our virtual machines, our users, our data, our anything under the sun, pretty much. And I'm pretty delighted to be joined by one of our Checkpoint partners. So I've got Chris Beckett on the call. Chris, I don't know if you want to unmute yourself and just give a little introduction about yourself.
Yeah, happy to. Good morning, everyone. Chris Beckett from Checkpoint. I'm the Cloud Security Architect for UK and Ireland. I work in the European overlay team, so I work with some of the guys in France and the Nordics and Benelux and places like that. And I've been with Checkpoint since July, and previously to that, I worked in the cloud architecture practice at Capgemini.
So you've got the best of both worlds, basically.
Indeed.
Excellent. So, and just for the record, my name is Chris Kirk. I'm a senior technical consultant here at Ultima, and I cover Azure. I do my best to cover pretty much everything to do with Azure these days, which is a slight moving target, to say the least. So I concentrate on infrastructure as a service, platform as a service, automation, DevOps, and everything in between, it seems these days. It is a forever growing platform that keeps me very, very busy, as you could probably imagine. I'm trying to learn and keep up with everything that changes week to week, month to month, and year to year, it seems, at the moment. So in terms of what we're going to talk about today, it's more just to elaborate around not just security, but obviously combining that with Azure. And what we're trying to do with these webinars moving forwards is, I don't know if some of you may have been on the previous webinar we did last week, is as I said, because Azure is such a moving target, the whole point of kind of us engaging with these webinars a little bit more is to give you some of that real world advice effectively around certain topics where I think at last count there's 134 products in Azure. So there is loads of things to talk about. We're not short of areas to cover from a technical perspective in terms of giving that advice over to customers and make sure you can get the best out of using Azure, even if you've been using it for a couple of years or you're just kind of just trialing it out. You've got your toe in the water, as it were, and you kind of want to know a little bit more about certain areas. So from the security one we're going to do today, we're going to talk a little bit about security best practices, and that's going to form quite a large area around what's referred to as role-based access control. But we're going to do obviously the general security around that. But as you'll see as we go through the slides, it all comes down to who has access to what effectively, and we'll talk a little bit more about that in a little while. We're going to talk about what exactly a layer 7 firewall is in Azure, how that works compared to on-premise, and when we're not using a layer 7 firewall, how and what effectively are network security groups that reside in Azure. So we're going to talk a little bit about that as well, and the difference kind of between the two of them. And then once I've finished rambling on for a little bit, Chris is going to jump in, and he's going to talk about not just Checkpoint from a firewall perspective in Azure. He's going to talk about everything that Checkpoint does, because it may not be well known that Checkpoint do a lot more than just firewall software in Azure. They cover quite a few bases on that area. So just to kick it off with a bit of security best practices in Azure. Now, obviously, this is quite a wide area to cover. So we're just going to give you kind of what I consider the highlights or the important cliff notes when we're actually looking at security in Azure. So to kick it off, we're just going to give some general information around it from kind of a Microsoft perspective, and how that then relates down to what you should be doing from a security perspective. So Microsoft spend upwards of $1 billion a year on anything to do with security that exists for Office 365, Azure, Power BI, everything you can think of that is a cloud-based service. On top of that, they also have this concept of red versus blue war games as well. Now, that sounds slightly Hollywood-esque, I must admit, but it's to get across the idea that security is forever evolving, and we have to be very up to date in terms of what we're doing, in terms of exploits, in terms of the attack vectors that people are trying to use to obviously exploit not just a cloud service, but any service in particular. So it's just to highlight what Microsoft do is they have these two teams in Redmond, a red team and a blue team, and they are forever effectively one team is attacking and one team is defending, to put it in kind of a simple term. So one team is actually attacking the real Azure cloud platform, and the other team is trying to review those exploits as well. And after they've had a period of time at that, the teams will then swap over, and that's so that obviously they don't get complacent and everyone can get the full benefit and experience of that. So they are forever reviewing their security boundaries in real time with real attacks effectively on the cloud service. I mean, that does sound slightly crazy to think that they're doing that. And obviously they're not there to do anything nasty. They're doing it before someone else can get there effectively on that side of things. And how they then review their platform is they look at things like DDoS. They have real-time threat analytics on all the public endpoints, and they whittle that down to also the physical security side of things. So that there's obviously IP cameras. There's multiple authentication requirements to go into the Azure data center. They are practically a Fort Knox in terms of a security perspective to actually get into the data center, or what the engineers actually do within the Azure data center. However, it goes without saying that this is a shared responsibility. So while Microsoft will do a lot for you in terms of they're constantly monitoring their endpoints and they're doing things like dynamic denial of service prevention, it's still down to you at a certain point to look after your data and look after your servers, because Microsoft will provide all these lovely security features for you. But if you configure a virtual machine with a public IP and put a lot of data on that and then expose it with, turning the Windows firewall off, there's no security whatsoever from your perspective, that is down to you to protect that. That's not down to Microsoft. So it's important to remember that this is a shared responsibility in terms of security, that what we're actually doing with this. And in terms of actual kind of certification for security, Microsoft have as many certificates you could shake a stick at, to be honest with you. They've got ISO 27001, there's PCI DSS certified, there's SOC 1 and SOC 2 certified if you're kind of American slanted for your business. It's certified for UK G Cloud, EU Safe Harbor, and they are constantly reviewed and recertified. I think every 6 months for most of those certificates by an independent third party. And generally speaking, they will have, and this is no offense to any business, they will have more security certifications than anyone that you could probably do, or that you could probably do on premise, to be honest with you, in terms of the amount of security and time and effort and money they plow into this endeavor for you. So this kind of comes onto kind of what you do now at the moment in terms of moving that security model from what is your responsibility into Azure. So I'm going to make a bit of an assumption here that a lot of businesses will have dedicated teams for their IT. You're going to have a help desk, you're going to have InfoSec, your application team, your DBAs, your backup team, your Active Directory infrastructure. And I'm going to assume that all your users do not have full access to every server you have in your estate, because from a security perspective, obviously that is not that's not a particularly good model. Not because people are going to actively attack anything internally, but because if there is a security incident and a cat is compromised, obviously you don't want everyone to have full access to absolutely everything in your estate. And that applies to Azure as well as what you're doing on premise. And before we could do anything like look at our identities and look at who's got access to what, the first thing we need to kind of tick off our list is, how do we do our identity in the cloud versus how we do it on premise? And obviously the best way to do that is to have just one identity for both. We don't want to have a situation where we have multiple identities for multiple different systems, because from a security perspective, that is a bit of a nightmare to manage, maintain, certify, secure, and all the rest of it. Excuse me. So the easiest way to to do that is with Azure Active Directory and what we refer to as Azure AD Connect. So AD Connect is a service from Microsoft that you can download and install on premise, and it will allow you to synchronize your existing Active Directory users into Azure AD, and Azure AD can then be consumed by Azure itself, by Office 365, by Power BI, and any other kind of cloud service that exists in the Microsoft Cloud Stack. What the service will allow you to do is synchronize based on organizational units, or you can create some customized rule where you're only syncing the users that you want to into Azure AD. So that means you'll have one identity for all your users. The passwords will be the same. You can do password write back from Azure Active Directory back to on-premise. So if they change their password in the cloud, it will then change that password back to Active Directory on-premise as well. On the plus side, you're then going to get a load of benefits, including multi-factor authentication in your cloud service. It is a free service available in Azure AD to allow you to have effectively at minimum 2FA, which is going to be a phone call, a text message, or a hardware token, to give you that extra layer of security in Azure on that side of things. So that's how we could get our identities into Azure and have one identity for what we're doing on premise and what we're doing in the cloud. But how does that help us with securing our resources in terms of who has permission to do what, like we just talked about? So this is where role-based access control really does come into it from a security perspective. So role-based access control, or IAM, as it's sometimes referred to in the Azure portal, is effectively a hierarchical model of permissions. So in Azure, the general hierarchy is we have a subscription at the top level, we will then have our resource groups, and in those resource groups, we will have our resources, regardless of what they may be. So from a security perspective, I can assign an Azure AD user or group that I've synchronized into Azure AD and give them permission either on the subscription level, on a particular resource group, or on a particular individual resource that we have in Azure as well. In terms of what I mean by a bit of a hierarchy, if I apply the if I apply the permission on the subscription level, it is going to inherit that permission all the way down this little hierarchy we have here. So if I have, for example, a group of users that have full permission on the subscription level, they're going to have full permission on all the resource groups within that subscription, and therefore all the resources that existed, or all those resource groups as well. Generally speaking, you're going to have 3 different permissions available to you. You're going to have owner, which is full admin access, including the ability to change permission. You can have contributor, which is the same as owner, but you can't change any permissions or assign any permissions. Or you're going to have the reader role, which effectively is like a help desk permission, where you can see everything that you've been given that reader role access to, but you can't change anything. So it's effectively giving a second line support the access to actually see what's been configured and then kind of move it on as well. But in terms of how that affects our Azure design or our resource groups or our subscriptions, how do I apply a decent security model based on my users that may exist to what I've got on premise? And this is where kind of your resource group design kind of comes into it a little bit. So while we spoke about we could apply either Azure AD users or groups to the subscription, the resource group, or the resources, generally speaking, because of the contributor, owner, or reader roles, we want to design our resource groups around a common application or a common service, effectively, to simplify the permissions that we're going to apply. So, for example, I may have our network team, and I would then create a resource group that has all our production networking in a particular resource group and assign an Azure AD group that has all my networking guys so they can deal with the networking, but they can't see or change anything else in Azure, as an example. Another example may be my application development team. They have a resource group with a particular application that they look after. I will create an Azure AD group, give it full permission on that resource group, but they won't be able to interact or see anything else. So I'm basically assigning permissions based on the user's role and therefore limiting access to everything else in Azure based on what they generally have to look after day to day. And therefore, if there's any kind of account compromises or anything like that, you're effectively limiting the security footprint or the attack vector to what they can actually access. and you're just making sure that people aren't changing things that they shouldn't be, and you can keep track of things that are so much easier using this kind of model. It goes without saying as well that when you're assigning permissions in Azure, you should do it now. Sometimes you can't help this, but you should always do it using groups rather than users. So the reason you should use groups is because I can add a certain person into a particular group, and if they change role or they leave or something like that, it's so much easier to take them out of the group than it is to search for all my resources in Azure to find where exactly they've got permission to something for that particular user. You'll be there forever and a day trying to find all these little areas where they might have permission, where you could spend 10 seconds just taking them out of the group. And from a model moving forwards like that, it will save you so much time, and it would be so much easier for you to manage certain things like that moving forwards. But while we have permissions that we can set on the subscription and on the resource groups and on the resources, for customers that are using an enterprise agreement, there's also an additional security area that we have to consider as well, which isn't always that obvious when we always get an enterprise agreement set up. So with an Azure EA, you have this little bit of hierarchy that's on screen at the moment that's available to you, where you could create multiple subscriptions against either a particular department or a particular geographical location, depending on kind of how your business functions. And then you effectively have an account owner, or it could be a group if you really wanted to, that looks after that particular department or geographical area. So again, this is isolating the business to business units or areas of the business where we want to do something with Azure, but it's limited to that particular area. So for the security perspective, that's obviously a lot better, a lot easier to manage. And also, as an aside, from a billing perspective, it's also a lot easier, because then you can then track what costs are associated to what department or what geographical location of the business is actually being consumed in Azure on that side of things. So this is something very much worth exploring from an enterprise agreement if you are using that in Azure at the moment. Unfortunately, you don't get this hierarchy if you're using pay-as-you-go or cloud solution provider or CSP, but this is a purely enterprise agreement feature that is actually available to you on that side of things. So to kind of step it up a gear a little bit, we're going to get into a little bit more of the nitty-gritty now with the security in terms of the actual features that are available to us in Azure, predominantly around our infrastructure as a service resources, so predominantly our virtual machines and how we manage them in Azure. So we're going to talk a little bit about network security groups initially, and how they actually work as kind of like a first line of defense before we start doing anything fancy in Azure. We kind of first step into Azure, and we want to do something straight off the bat rather than absolutely nothing. So a network security group is an Azure resource that's effectively a software firewall available to us. So it allows us to create inbound and outbound access rules in like an access control list fashion. So we can have things like priority, for example, on our inbound, and we can have priority on our outbound rules. And what that's going to allow us to do is specify things like source and destination ports, or source and destination protocols, source and destination IP addresses or IP ranges, for example, to limit what is allowed to traverse this network security group, regardless of what we have on either side of it effectively. So for example, within Azure Virtual Machine, if we have an Azure VM and you want to expose something to the outside, and for whatever reason you've assigned a public IP address to that Azure Virtual Machine, you would at minimum put a network security group on it, because obviously you want to limit the exposure that virtual machine has to the outside world if you have that kind of setup already in your Azure environment. You certainly would not expose an Azure VM to the outside world with a public IP without using something like a network security group. And I'll get into why that may be in a couple of slides time. So in terms of actually applying a network security group within your kind of existing Azure environment, you could apply it in two different ways. So you can either apply it directly to the Azure virtual machine itself, as I just mentioned, or you can actually apply it to the subnet in your virtual network. So that means that any virtual machines that connect to that subnet will automatically inherit the network security group rules that you have created and assigned to that object, and they will get inherited by the virtual machine automatically. And this comes to the point where in the real world, from my experience, you wouldn't assign network security groups to just virtual machines. You would assign them to subnets, and therefore you want to kind of simplify those rules. Otherwise, you're going to end up with lots of network security groups, and it's going to be a little bit of a nightmare and a little bit of overhead for you to manage all those different network security groups. So when you're designing your subnets within your virtual network in Azure, you want to have those subnets around something quite common. So therefore, you can design network security groups that have a very common rule set to what you're doing. So you may have a subnet, for example, that has front-end servers, and you may have another subnet that has back-end servers, such as database servers, for example. Because by default, all subnets in a virtual network can talk to each other straight out of the blocks, effectively. So if you want to limit that, for example, you could apply a network security group to your front-end subnet and a network security group to your back-end subnet, and therefore limit communication between the two, or limit exposure if we're using any kind of public IP addresses. It should be noted as well that if you are using, for people that are using Azure already, if you are using a gateway subnet, i.e. you have an express route or you have a VPN set up in Azure to the gateway subnet, you can't apply a network security group to the gateway subnet itself. It's not supported in Azure. So you have to manage the security of that back to whatever you're connecting back to on premise, or you can manage the security via your ISP, who's obviously helping you set up that express route side of things as well. If you have to troubleshoot network security groups, then you can use something called Network Watcher. It's another resource available to you in Azure, and that will allow you to plug in source and destination IPs, and is that going to be blocked by the NSG or not effectively. So that's a great troubleshooting tool available to you. If you've applied an NSG and for some reason the traffic's not getting through, for some reason you're not quite sure why, you can load this resource up, enable it, and then it will allow you to troubleshoot endpoints effectively, and it will tell you what rule is blocking it on what network security group, if any, on that side of things. But to bring it back again to the real world side of things that I mentioned, if you have this setup of a virtual machine and a public IP address against it, this is a screenshot from my kind of, we'll call it a honeypot lab effectively, which is an old school security term. So I have set up here a virtual machine with a public IP, no NSG, and no Windows firewall on it. So I've exposed it to the outside world via a public endpoint, and I've just left it running in an isolated environment just to see what would happen. So as you can see from the screenshot on the top left, this is the last 24 hours worth of data that I've recorded in an Azure monitoring solution called Operations Management Suite in the security feature that's available to me. And I have had 10,000 failed logons to that box, and that is RDP brute force with users trying to log on to this box. So you can see a list of accounts that's just tried. Administrator is always going to be the favorite, but you've got things like Chris and David, SQL admin, test one, test. The list goes on. And this is just to demonstrate the fact that if you are using public IPs, please limit the exposure to what those virtual machines have to the outside world, because this is the result of not securing your virtual machines properly. Azure is very smart, and there's lots of DDoS and there's lots of brute force analysis going into this to stop this kind of thing. But if you're exposing it to yourself, then eventually you're at risk of that virtual machine being compromised, and therefore the rest of the environment potentially being compromised as well, if you don't have MFA enabled and they guess a password correctly to a particular user. So that's just to demonstrate in the real world what actually can happen if you don't actually put some security in place when you're using public IP addresses for your virtual machines. And again, just to highlight with the network security group side of things, the reason I was saying about simplifying them, again, is because we don't want too many network security groups, because it will be an absolute nightmare to manage that. And it only takes one person to miss a network security group and miss a rule setup or something like that to bring the whole thing down like a very shoddy deck of cards effectively. So rather than applying public IP addresses to virtual machines and using network security groups to protect them, there is actually a better way to do this in Azure to kind of limit the exposure to your virtual machines if they do need internet access for various services, or you need to have inbound access from the internet come into solutions that you're using in Azure, but you want to secure it in the best possible way forward. And that is something referred to as a hub and spoke design from a network architecture in Azure. So this is a very kind of simplified diagram, don't get me wrong, just to demonstrate kind of how this may look if you were to set this up. So by hub and spoke design, what we are referring to here is we are having a central hub of a virtual network that sits in the center, and that deals with our inbound and outbound access at a single point for everything in the solution. So we have separate VNets for our different environments, so production and development in this case, and they could talk back and use the shared resources in the hub via what we refer to as VNet peering, which are low latency connections that exist within the Azure data center. We can then basically use what's called a network virtual appliance to then control our inbound and our outbound access for all our virtual machines and not expose those virtual machines individually using public IPs. In this solution, the network virtual appliance is the only one with public IPs assigned to it. So that is how we get in and out from an outbound access, and also how customers can then come in to the solution in terms of accessing other resources. And an NVA is effectively the same firewall solution that you're probably using on-premise today. So you're basically mirroring kind of in a kind of roundabout way what you're already doing on-premise. You're creating a central secure security VNet, for want of a better way of putting it, and then controlling that firewall solution in terms of NATing, in terms of network rules, in terms of website allowances, in terms of general compliances, and everything else under the sun. Now, this doesn't interact with your connection going back to on-premise if you're using a VPN or express route. This is purely for outbound access if you need to expose something, if you need to use internet access in your solution. And just to highlight, via NVA, this could be a Fortinet, this could be a Cisco, this could be a Palo Alto, and obviously with Chris on the line, I have to obviously mention this. Obviously, it could be a checkpoint as well. So all your major vendors are available in Azure in the marketplace as a network virtual appliance for this very reason, to have a secure point in and out to your Azure solution, rather than having network security groups all over the place and public IP addresses all over the place. In terms of how you actually forward outbound access for your virtual machines to that appliance, we have something called user-defined routes or route tables, where I could basically override the default route in Azure to say, rather than go out the internet in air quotes, which is going to be just via the public IP or the Azure data center, I want you to send any traffic you don't know about, i.e. internet traffic, to this particular IP, where that IP will be the IP address of that network virtual appliance. So I could basically override all my virtual machines for their default route and tell them to go via that network virtual appliance if they don't know where that traffic is actually meant to be going. So that doesn't affect traffic going outbound to on-premise, because that is already being injected into the route tables anyway in Azure. This is purely just for outbound access. And it's also worth noting that if you are thinking about it, you can't completely cut off your virtual machines for outbound access 100% in Azure and then stay online and completely healthy. In Azure, your virtual machines need effectively HTTPS access to the underlying Azure fabric via a set of URLs. So if you cut off via, say, an NSG, for example, a network security group, sorry, for example, completely, that virtual machine will probably work for about a week, and then you'll start seeing very odd behavior, and then you may go to reboot it, and it probably won't come back online because it will try and contact certain URLs on the boot process, and it won't be able to, and it'll probably sit there trying to boot forever. So it's worth highlighting that you can't completely take away outbound access because it's a cloud-based solution at the end of the day, and it needs certain access to HTTPS URLs under the cover. But if you are looking to secure your solution going forward, the hub and spoke design and something like a checkpoint as your network virtual appliance for your single inbound and outbound control point in Azure is absolutely the best way you should be doing that from a security standpoint, rather than having all these public IP addresses all over the place. I can't stress that enough from a security perspective in terms of actual best practice, but also what we've seen what I've seen outside in the real world kind of thing. And just before I kind of hand over to Chris, it's just worth noting that if you are an existing customer or you are looking at an Azure project in general and you're kind of fairly new to Ultima, we cover obviously Azure for every avenue for customers. We can do things like security reviews, we do DR services, health checks, design workshops, proof of concepts. We do large Azure migrations and everything in between. So if you are thinking of something to do with Azure or you want some assistance with something, it goes without saying, have a chat with your account manager if you have one assigned, or if you are talking to someone in general at Ultima at the moment, if you're new to us. Have a chat if you're thinking about something, and we could probably help with it, as we do this all day long. We have a team dedicated to Azure, and we have a team dedicated to security that work very closely with us as well. So we could probably help you with quite a few things going forwards on that side of things. So that's it from myself at the moment. If you do have any kind of questions at the moment, we'll take them at the end. We've allowed a little bit of time before we close off the webinar, and we'll kind of review any questions you may have. But for the moment, I'm going to hand it over to Chris to talk a little bit about Checkpoint, which I'm actually quite looking forward to, because I think I'm actually going to learn something, which is always a nice thing. So Chris, I'm just going to make you a presenter.
Okay, thank you. Let's make sure we can make this work. Okay, is that better? Can we see that?
I can see that.
Okay, excellent. So this is going to be a bit of a collector's item, in the sense that it's not a Checkpoint slide deck that has 90 slides in it. It has just the one, and that's deliberate. And the reason why is because one of the things that Chris mentioned previously was Checkpoint, oh, you're just the firewall guys. Well, yes and no. Firewalling is something we've been doing for 25 years. We're very good at it. We believe we're the market leaders. But also, the world's changing. You know, we're not just talking about data centers and physical tin and gateways anymore. We're talking about cloud. We're talking about, you know, serverless, platform as a service, software as a service, etc. And we've got to move with the times to go with that. And it's really about attack vectors, and in terms of how best can we help protect customers and keep the data safe and the services safe, etc. So in that respect, what I want to do is just quickly go over what we call our 360-degree cloud security view. And the reason why it's called that is because we've got three main cloud products in the portfolio, and they're very complementary to each other. There aren't any overlaps, and they've got sort of very sort of specific use cases. So starting at the top left, because I'm conscious of the fact we're talking about IaaS quite a lot, so I'll come to that last and spend a little bit more time on it. But starting on the top left, we've got a product called CloudGuard SaaS, which is relatively new. This was released into GA probably about 2 weeks ago, something like that, but it's been kind of boiling for a while with quite a lot of EA customers. And the whole point of CloudGuard SaaS is it's a protection tool around essentially end user facing services, so the likes of Office 365, G Suite, Box, Slack, etc., ServiceNow, as you can see on the slide. And the ability that gives you is, like a lot of cloud services, with the fee that you pay for, you know, like networking and etc. and DDoS, you'll get a foundation set of controls, which is fine, and it kind of gives you a little bit of coverage. But the thing is, if you want to build a more enterprise class solution, and if you want to have more protection on top of that, you're going to have to pay for it. So with the foundation controls that are within some of these already, and there are also some functionality gaps as well that we help to plug. So things like zero-day protection, it's inbuilt into Sandblast and Threat Cloud. So all of the sort of technologies that you're already maybe familiar with within sort of physical gateways in the IaaS world. Identity protection, DLP is always quite a big one. So people within Office 365 and G Suite sending out emails with things like credit card details in them, national insurance numbers, that sort of thing. Anomaly detection. So again, there are some base functions within Office 365 and G Suite to detect things like, Fred is based out of London and he always logs in London, but then suddenly today, 5 minutes after he logs in London, he's tried to log in Moscow, for example. We know that's clearly not right. That's anomalous behavior, so we send out a flag on that. Another key aspect of CloudGuard SaaS is shadow IT discovery. So one of the common problems around cloud is it's so simple to go to a web page, sign in with your email address, register with that, give it a credit card, and then off you go. You can do whatever you want pretty much. And that's called shadow IT. So one of the things that CloudGuard SaaS can do is typically when you sign up to these cloud services, you get an email back from the provider saying, please click on this link to verify your email address, and then, let's get going sort of thing. CloudGuard SaaS has got a list of known sort of email addresses and domains that these come from. What it'll do is it'll realize this, it'll send kind of a flare up to the administrator to say, this guy over here has spun up an Azure subscription, you might want to see what's going on in there. So you can then go and speak to this user and say, we want to make sure that A, you're not spending a lot if you've got a company credit card, but also B, what data are you putting in there? What are you doing with it? Is it publicly exposed and things like that? So you can get some subscription details and some credentials, and then the product at the bottom, which is Dome 9, can essentially plug into that environment and monitor it and make sure it's compliant and things like that. Dome 9 is a cloud security company that Checkpoint acquired about 4 weeks ago. It seems like a lot longer than that, actually, because we've done so much talking about it in the last few weeks. But Dome 9 is a built in the cloud company. It's not just about IaaS, it's about being API driven into Azure AWS and Google Cloud Platform. So the three main public cloud providers are covered kind of from the get-go. It's a completely SaaS service. There's nothing you need to deploy on-prem. It's literally just get some credentials into a subscription or an AWS account or a GCP project. It can be read-only. It doesn't have to be read-write. And typically what we find is customers that are doing POCs will point it at their production environment in read-only mode. So automatically they're seeing anything there that, any sort of red flags that they need to look at. And Dome 9 uses the management APIs across the three platforms. It also has its own API. So if you're in an environment of DevOps or CI/CD and all these sort of new ways of working, you can build Dome 9 into part of that build pipeline process. So for example, part of your build pipeline is submit some code, run it through Jenkins, and then you can fire it off to Dome 9 to do a bit of sanity checking around what security group rules does it set, which region does it go in, and other such things like that. If it passes all those tests, it can carry on down the build pipeline. If it fails, obviously the build fails, and then you've kind of got to go back to the start again. But Dome 9 is built around the idea that we're no longer sort of the network perimeter is no longer the security boundary within the cloud. It's moved kind of to other places. So for example, PaaS hosted services, SQL Server, and things like Elastic Beanstalk maybe in AWS. Serverless functions as well, so Lambda, Azure functions, all of which have sort of publicly accessible endpoints. We can't just think about the network anymore as being the sort of security bubble. We've got to think a bit bigger than that. And Dome 9 is really the way that Checkpoint complements CloudGuard IaaS with native cloud security. So Dome 9's a great example of one of those things. In CloudGuard SaaS, you can do something similar. You can go into the portal. You can sign up for a trial account. You get, I think it's 14 or 30 days unrestricted free trial. Plug it into some of your cloud accounts, even if they're only test ones, sort of see what it can do. And then, if it's something that you like and something that you think adds value, then obviously come back and talk to Ultima and we'll kind of take it from there. But Dome 9 is very popular in respect of compliance, very popular in the financial services industry. So there are pre-potted checks in there around things like PCI DSS, GDPR, ISO 27001, all of those usual sorts of things. So you can very quickly run a report with a global view, so not just sort of looking at Dublin or Amsterdam or UK West or whatever. You can very quickly see if you've got any exposed resources within your environment, and not just VMs, but things like S3 buckets, Azure storage, those sorts of things. But you can also construct your own security templates to run some checks. So, for example, a good one on a customer I worked on about a year ago was having data in Germany was an absolute no-no because of data protection reasons or something or other. And they had quite a lot of intellectual property that was very, very valuable that they didn't want to let outside of the UK. So one of the things you could do within Dome 9 is to add a bit of logic to say, don't allow anyone to deploy virtual machines or services outside of the UK. And if that happens, let me know about it and I can do something about it. So I don't want to dwell too much on Dome 9, but it's important to kind of see how that holistically fits into the bigger picture in the Checkpoint Cloud portfolio. Now, in the top right, obviously we spent a lot of time already looking at IaaS and IaaS protections within Azure. CloudGuard IaaS is our product within Azure and all these other clouds. And hopefully what you'll see at a first glance from that top screen is that there's really wide platform support from CloudGuard. So we support AWS, Azure, Google Cloud, Alibaba, Oracle Cloud, VMware and AWS. And then in terms of the private cloud world, OpenStack, Nutanix, KVM, Hyper-V, Nuage, vCenter, NSX, and Cisco ACI. So market leading in the sense that these whole raft of platforms we can support. Now, couple of the key differentiators for Checkpoint is that all of these environments are going to take some managing. Now, what you can do with CloudGuard is have one management box to rule all of those platforms within CloudGuard IaaS. So from the same management box, I can set access control rules for AWS and for Azure and for OpenStack. It doesn't really matter. And that's a key differentiator for us. Now, one of the things about cloud is good at a lot of things, and it's easy to dial up and dial down services and stand up very complex environments from pre-templated things from the Azure marketplace, and that's great. The one thing that cloud doesn't tend to do all that well in my experience is logging. So you'll configure an Azure storage account or an S3 bucket and you'll throw the logs in there. And then essentially it's down to you as an end user to go in there and look at it and try and make sense of it, try and put some context around it. Use your favorite tool, whether that's Power BI, Crystal Reports, Excel spreadsheets, whatever that might be. But that's very time consuming. So one of the things that CloudGuard IaaS has within the management tool is the centralized logging feature called Smart Event. And what Smart Event does is correlate all the logs from all these different platforms, have it in one place. It's very quick to read. It's got a Google type indexing engine within it, but also wraps context around the logs. So you know what a service is, you know what something is on a particular port. Source and destinations will have a context around them so you know what they are. And it helps you very quickly identify what's going on in your environment. Now, leading on from that, one of the things Chris mentioned was about network security groups. And in my view, not just cybersecurity, but the whole security landscape in general, you shouldn't really be looking for one silver bullet, because I don't really think that exists. I think it's a layered approach made up of many different things. And they include things like network security groups and include identity and access management and endpoint security and DDoS attack prevention and a whole raft of other things. And cumulatively, they will build up your 360-degree kind of security posture. NSGs are useful and have the place, but they are limited, and it's important that people understand that, because the first question we get with Checkpoint is, well, I've got network security groups, what do I need you guys for? Fair question. Now, the thing with network security groups is, think of them as kind of a bouncer on the nightclub door. So they basically have a list that says you can come in or no, you can't. And that's essentially what an NSG is. So there's no real introspection as to what the payload of the packet is. It's only looking at where it's come from on what port and where it's going to and what port. And if you're on that list, great. If you're not on the list, you don't get in. That is one aspect of a security posture, and that should form part of this kind of layered shell, if you will. But if you want to be able to inspect within that, so for example, if you've got a web server and someone's trying some targeted attacks, some intrusion attacks on that web server, a network security group isn't going to stop that. It's still going to get through. And then you're relying on things like, is this web server patched? Does it have endpoint security, etc., etc. So within Checkpoint CloudGuard, we've got a blade called IPS. Now, IPS is the one that looks for intrusion protection, and it's basically got the highest catch rate in the market, so something like 99.96% catch rate, which is the market leader. I know Chris mentioned some of the other vendors, and I'm not in the habit of bashing them. You know, we all do something really well, but our IPS protections are noted by third parties, NSS labs, etc., as being the best in the market. Now, as well as that, within the product suite, because the CloudGuard IaaS virtual machine is pretty much the same as a gateway, you get all the same blades that you would have got before. So things like URL filtering, application control, antivirus and antibot, data loss protection, and advanced threat protection. But two key features for the cloud that I quickly want to touch upon are the controller and auto provisioning. So the controller is a service that runs on the management server that logs into your cloud platform of choice with read-only permissions and extracts out characteristics of the workload within that cloud. So for example, tags, regions, network security groups, availability zones, all those sorts of things. Now, what's important about that is that the access control policies that you build within CloudGuard IaaS can have those objects within them. So traditionally within Checkpoint, new host comes onto the network, you've got to assign it an IP address, you've then got to create an entry in the CloudGuard database for that host and add it to a subnet or maybe a group, and it's quite, the management overhead is quite large. So within the controller, what we're looking to try and do is to try and make this environment as zero touch as possible and think about the management server as a bit of a black box. So what the controller will allow you to do is set an access control policy to say something like, if a VM has a tag of web server, then we'll allow it out to the internet. And if it doesn't have that tag, then it can't get out. So every time a workload is spun up with that tag on it, the gateways will automatically recognize that and let that traffic pass. But you don't have to do anything to the access control policy because it already knows. And that controller support is not just for Azure, but it's for AWS, Google Cloud, and a host of the other on-prem ones like NSX and OpenStack, etc. So that is a really powerful feature that we've got within Checkpoint that's unique to us. And actually, if you've got a Checkpoint management gateway now, it's already in there. It's not an extra license or anything like that. It's completely free. Turn it on, hook it up, and have a look at the sorts of things it can do. And just quickly, I want to touch on the auto provisioning. So obviously in the cloud world, things are very much geared towards auto scaling, so scaling in and out. We fully support scale sets within Azure. We've been doing that for quite a long time. And within that, every time the scale set horizontally scales out, so we add more gateways, the auto provision service will recognize that that gateway is in Azure. It will add that into the Checkpoint management server. It will turn on whatever functionality blade you want to turn on and then push down the security policy. So you literally, when a scale event happens, it can happen overnight. You can be in bed. All of that is handled for you. You don't literally have to do anything at all. It's all zero touch. And conversely, when that scale set comes back in again because the load's dropped, those gateways then get removed by the auto provision service. That runs every minute. So you can see very quickly that there's some obvious real benefits from CloudGuard IaaS. And just to quickly close on that, in terms of time to deployment, it's very, very quick. So to deploy a management server at a very basic level, probably about half an hour, and then to build a scale set and an auto scale group with the templates that we publish in the marketplace, around 15 minutes. So within a very short period of time, obviously there's some configuration work to be done after that, but within a very short period of time, you can have a very functional working environment. And because we're in the marketplace now, it's very easy for you to go in, try it out as a pay-as-you-go, pay a few quid for it, see if it suits your needs, you know, kick the tires on it, and we're more than happy for people to do that. And then if you find that you want to take the discussion further, as Chris says, come back to Ultima. They're a very strong Checkpoint partner, and we can kind of take it from there. So I realised that was a little bit of a car wash, and I went through it quite quickly, but there's so much to try and cover, and hopefully it's emphasised the fact that we're not just the firewall guys anymore. We do a whole lot more than that, and we've got these three products that complement each other very well to kind of cover all aspects of your cloud workloads. So with that, back to you, Chris, and thank you very much.
Cheers, Chris. Even Even I learned something on that, I must admit. So it's good to see, I think, for everyone, just when you talk about like Checkpoint and other vendors, you do think firewall is probably your first guy to go to. So it is really nice to see what else is out there, especially where things are now very much cloud orientated and where people are or everyone's looking towards the cloud into the Azure or maybe AWS or some other cloud. It's good to see that there are kind of vendors treating it, I say for want of a better way of putting it, treating it seriously and having other bespoke solutions available to you to meet kind of security needs. So that is effectively what we were going to cover today from a security perspective in Azure. I don't know if anyone has got any questions they'd like to ask at this point. Anything that we've covered so far. Like I say, if you don't have any questions right now, feel free to talk to your account manager about anything you've kind of got ongoing at this point. As I say, we're going to try and do more of these webinars moving forwards. We've got one in the works for February next year, and there's a few others beyond that that are still in the planning stages at the moment. If anyone has any kind of other questions or at all. So there's no other further questions as far as I can see on the webinar. So if you do, like I say, if you do any further questions, feel free to reach out to us and keep your eye out for more webinars. And I'd just like to say thank you very much for your time. Thank you to everyone for attending, and hopefully it's been a nice learning experience for you. So have a good day, and for everyone else, have a good Christmas.